right, welcome everybody. I am your host, David Aponte, and we're going to have a very fun session today about CICD, or continuous integration and continuous delivery. And we're going to apply within the context of machine learning. I have a really awesome guest today. I have Elle O'Brien, and which I'll introduce in a second. But she's been working on a really awesome project, which we're going to get to in a little bit, that relates continuous integration and continuous delivery to machine learning. And we're going to talk about CI/CD in general. We're going to talk about why it's difficult for machine learning. And we're going to get to know a little bit about this new product that I'll get to that in a second. But without further ado, let me introduce our guest. We have Elle O'Brien with us. She's a data scientist at Iterative Inc., the team behind DBC. So if anyone has used DBC for versioning their data or doing any sort of, I guess it's like Git for data in some ways, right?
Yeah, that's the tag, yeah.
She holds a PhD from the University of Washington, where she previously conducted research in computational neuroscience and was working also on speech perception. She's also worked as a chief scientist at Botnik Studios, which is an AI comedy writing collective. That sounds super fun. Just before we even move forward, what is an AI comedy writing collective?
Yeah, it's a bunch of comedy writers and then a couple of us that are into web development and ML. And then we put together kind of predictive text keyboards, and then all the comedy writers go to town with it.
Man.
It's great. I mean, we had some things like, it was, yeah, we had a Harry Potter book chapter that went viral. That's what we're most known for. Yeah, that, and I think we had like a Seinfeld script that did really well. You know, it's just like a weird bot writing, human hybrid.
Cool. I hope I'm not embarrassing one of my coworkers, but I work with someone who is into basically like tech comedy, and he's done some stand-up before, and I just love it because it's, you know, that integration between like talking shop, but then also being funny and like, you know, kind of being able to joke about it. I love that. Probably one of the primary reasons why I'm on Twitter, just to see the memes and the kind of the jokes about what we do. But yeah. Anyway, we have an awesome guest with us today. And before we even get into CI/CD, I would love to know a little bit more about you. I've gotten the chance to speak with you a little bit, seen you in the MLOps community chat, and you're working on really interesting stuff. So even before we get into it, how did you get into the space of machine learning?
Yeah, so I did the last 10 years of my life have mostly been in academic research in some variety. Like when I was an undergrad, I just like ended up working in a neuroscience lab because I didn't want to go scoop ice cream for the summer. So like, I mean, I just applied because it was a thing that paid for the summer. So I got started that way, and I just kind of never left for a while. I mean, I did go in and out a little bit, you know, but I was always kind of nearby people doing academic research or involved in it. And I wrapped up my PhD in January or November, actually, technically is when I defended of last year. And I had always worked around kind of problems in biology, but using mathematical modeling. Like my favorite tool has always been getting to use a really big computer to run a mathematical model. I love that. I never really wanted to be hands-on with like, you know, any kind of subject or any kind of like wet lab models. I just wanted to be on the computer all the time. And it was cool, you know, and I ultimately decided I didn't want to keep going and do like a postdoc, which is kind of the standard route. And I think a lot of that had to do with like, I could see that there was a lot going on in ML, and I was really having trouble kind of combining that with, you know, the scientific work. And it kind of felt like a place, you know, ML was a place I wanted to be because, well, there's a lot of action here right now.
Yeah, tons of action, lots of hype too.
I mean, yeah, a lot of that. I mean, one thing is like when I worked in a lab that like, I have a paper that I'm working on right now, and it's about like lobster digestion, and like, there's no hype there. Like there's no spin, you know?
Lobster digestion.
Yeah, it's a mathematical model for neurons of the stomach of a lobster, and it's cool.
That's pretty cool though, yeah.
But it's like, you know, I miss how hypeless that was, you know? So,
yeah. There's definitely a ton of that, you know. I feel like it may even take away some of the joy. But one question I have is, so coming from this research background, now working as a data scientist where you're building this product for production use cases, right? How was that transition? Was it hard? Was it very different? Did you notice a big gap between what's going on in academia versus what's going on in industry?
Oh, it's huge. It's so much bigger than I ever thought. I mean, I always thought like as a student, I was like, I'm great at coding. And then it turns out I get here and I'm like, oh, not quite, like there was a lot to learn. There was so much that it turned out, because I just feel like the standards are different. Like as a student, you have to code a lot. As a scientist in general, you have to code, but like nobody ever checks it. You never publish it. There's not like code review. There's not like, most people don't have even like a GitHub repository. So it's like, as long as it seems to be working, nobody's ever going to look at it or try to figure out what you did. And now I'm working in this organization where like, it's incredible. Like people deploy software sometimes like several times a day, it's really cool. And there's all of these like practices, and it just completely wowed me how much better life can be when everybody's like got a workflow of like, okay, you're checking in your code now, we've got a branch, we're going to merge it, we're all going to discuss it. Like it's great.
Yeah, for sure. I feel like for me, one of the differences I notice is like the it's like a way to collaborate and thinking around that, where it's not just like my own brain and my own thoughts and my own ideas, right? I have to share that and I have to distribute. It has to be reproducible. It has to scale. So it's like the same thing, but then kind of like blown up. But I do think that there's definitely some very different ways of approaching it. I'm sure it's very valuable too, though, to have done some research. Would you agree? Did it help inform the way that maybe you think as a data scientist?
Totally. I mean, I feel like I really got the best possible statistical background that I feel like anybody, like, I'm so happy with that. And I really think it took like all 10 years to learn it, and I'm sure there's more. Like if I had kept going, I'm sure I would have discovered like it goes even deeper. And I just feel like the ability to kind of look at a model and go like, this is probably junk, is like something that I feel like took years to kind of discern. And so right. And so I don't think I would trade that, like I feel like it's a complementary training, but it is hard to do both, because if it's hard to do like push this level, like production quality code is not incentivized very well in labs. So that's tends to be difficult. And likewise here, there's not as much incentive. I mean, also because I'm not like, a lot of times my data science projects are really working on tools. So now I'm not really as involved in like making inferences or, something like that about, I'm not
like really an engineering sort of role, it sounds like.
Right, exactly. So I miss that sometimes too, so there's lots of aspects.
Yeah, I feel like in my current company, I was working at first on the core engineering team. Now I'm in the core model development team. And that I kind of sit in between those two things, the research where there's lots of ideas, lots of things that may not actually make it into production, but then also knowing how to actually productionize these things. And it's tough to balance, I find. Like, I find that I'm a very slow thinker when it comes to modeling. I like to, I have like an arts and crafts sort of approach where I like play around, and I explore ideas, and sometimes it's just this crazy tangent. But when I'm like engineering and I'm building something, it's much more rigorous. I'm much more organized. I'm not an organized person in real life. You could ask my wife. But when it comes to engineering, it's like, I'm like, I got to do this because I'm building something. I'm thinking a little bit differently. But I do think that it actually is a strength of, and I'm sure you would agree that now thinking about how to put something into production, but also knowing how that algorithm works, how to really have an intuition around a good model or a bad model. That's invaluable. And I feel like, you're saying it, you've studied this for years. I have so much to learn. It's a vast field of math, right? And to me, honestly, a lot of the modeling is math, right? A good foundation on statistics goes such a long way in data science.
Yeah, absolutely agreed. And there was something you said that like, it sounded very close to my own experience too, of like, when you are going on tangents and like, I mean, I think one of the best things about doing like best and worst things about doing like pure data science is like, you can be like in a rabbit hole for a month of just trying things out or exploring, and nobody comes checking, about your progress. Like it's hard to know what's progress. So you can really like get into something by yourself. And then it's just totally different from the expectation of like, I'm going to check in code once a day, roughly.
Mm-hmm. And another thing I'm noticing too is like, it's hard to quantify the value of some of that research, at least in my mind. Like when I think about like talking to stakeholders or like I just had a review at my job, so I had to talk about my accomplishments. When you're talking about engineering, it's like, oh, I built this, I built that, fix this, fix that. But if it's a research project, it may have been actually we learned a lot from this, this rabbit hole, this tangent, but it was never productionized. So it's hard to to, I guess, immediately demonstrate to a stakeholder the value other than, we learned that, we're overfitting when we do this or something like that, So it's
Yeah.
hard.
It's hugely hard. I mean, it's so hard in research too. Like one of the reasons I also was kind of, looking to try something different than academic research is that there's so much pressure to publish because like publish is the metric, right? It's like how much code did you push that gets merged into the main branch is one metric of productivity. And in academia, it tends to be like, how many papers have you done? And like sometimes your discovery does not warrant a paper, but it was still very valuable. And like there have been Nobel laureates that would go like years without publishing sometimes in between, discoveries. And so it's incentive structure that I didn't feel thrilled to be dependent on.
Yeah, I haven't done a PhD, but working with a lot of PhDs, I hear a lot of war stories or how that this pressure to publish a lot can be overwhelming. It's very it's a lot, but it's also, I feel like a lot of people learn so much from that. I'm sure you did too. Putting all that time on one problem, focusing on that. It's, I think, invaluable to be able to learn how to do that, to stick to something, but it's great to also like play around and do a lot of different things.
Yeah, I think it's cool that right now is kind of like it's like I feel like it's easier for somebody like me to transition into a community like this. Probably, I don't know for sure, but it's like a good moment where there's enough overlap of like if you've done a lot of coding.
Absolutely.
Like data science is open, right, to people that are not like master coders that are like maybe competent, but you don't have to be a pro and you can still kind of get in here. And that is a cool opportunity.
Oh, 100%. I have, I just, just a little tangent, but I have friends and family, who never, undocumented, maybe not legal in this country, and struggle with finding, a way into, a good career. To me, technology, data science, machine learning, it is like, it's really all about like, it's a meritocracy. If you can learn these things, and you can, there's so much content out there to get you up to speed. But it is, I do think like I'm glad that you mentioned that, you spent a long time and you're glad that you did it, because there is a little bit of, sometimes shallowness. People can, follow some tutorial and think that they fully understand the real fundamentals. But it's so good to also have people that have, years in that one field. But I also appreciate the people that are coming from something different. I myself, I was a teacher. I was in a completely different field, but I was able to make it. And I think that there's something about, maybe it's just how it's a lot of open sourceness. I don't know, the type of people that are in it, but it is a great place for opportunities. I don't know how else to describe that, but maybe you kind of get what I'm saying, where it provides a lot of opportunity.
Yeah, totally. I mean, it's like there's so much that you can do now to teach yourself. And I mean, that was a lot of what I did in my last 2 years in academic research was like, I picked projects in data science that like, I knew nobody was going to give me credit for academically, but just, was what I wanted to learn, because I felt like, okay, I can't miss out on everything that's happening in ML. Like you could kind of see that this was very quickly changing a lot of the ways that we do predictive modeling. And I basically just had like this big fear of missing out. And I was fortunate enough to be in a place where like, I was okay that I could like devote the time, and I think like not everybody has that ability to put some time into learning these skills on top of their full-time job, which can be pretty rough. But I just got lucky that like it worked, and part of it is like the job I had was really flexible. If I just wanted to code for 8 hours, how to try to figure out how do I make a CNN, nobody was going to come helping,
That's wonderful. And I think this is a good time to now start diving into the meat of this. Now that we have a good understanding of Elle, definitely reach out to her. She's awesome. But today, the bulk of what we want to talk about is CICD for machine learning. And before we even get into any of that, it'd be great to I know a lot of you guys are engineers and scientists and you're sure you're familiar, but let's go to the basics. Let's talk about what continuous integration, what continuous delivery is. So I'm going to start with continuous integration. Did some research and kind of got this decent definition. It's about when you have, let's say, some mainline code base, but then you have a lot of people working on it and they're making variations of it. Maybe you're adding a new feature to this code base. Maybe you're fixing something. Maybe you're just trying out some experimental thing. But at some point, you're going to have to integrate that into the mainline code base. And maybe you're doing this actually multiple times. In fact, usually you're doing it multiple times a day and multiple people are working on the same mainline code base. So generally, you take some copy of the code, do some stuff to it, right? Push it back to the master branch. And you're going to be doing this in some regular way. Now, the tricky part about this is how do you coordinate all these different things, right? How do you coordinate all these different features, these bug fixes? Because I don't know about you, but I've definitely been in integration hell before where there's merge conflicts, someone, started fixing something, made all these changes, but didn't really, write it on the merge request and let people know, but we merged it anyway. And then we're finding out everything is breaking downstream. But it's basically this practice where you're trying to continuously integrate a lot of people's work. Any thoughts on that?
Yeah, so you want to be checking in pretty frequently. So you don't want to have like, your own feature branch where you're working on something and you go weeks and weeks without checking that against what is happening, on the main, which is often a production branch for, a typical kind of software project. And the other idea that I think goes with it is that every time you're checking in your code, you're also going to be testing it. So you're testing all the time. And this is kind of like a like a standard of DevOps, which is the idea, we always practice testing our code. We always practice what would it be like to have this in production. We're going to be pushing code, doing that very frequently. We never get out of practice.
Yeah, I love that point about, don't let a merge request stay out or pull request stay open for too long. That's a tough one, right? You have another one that I think is good practice is smaller ones. If you can kind of like keep it on one thing and do that one thing well. And then if you have another idea, you notice that, I want to do this, open up another merge request or pull request for that. But it's hard to do all these things, right? There's sometimes, you're waiting on someone else's work to continue your work. So then you have to keep this branch open for a long time. And then, someone else fixes something because, the production system worked, but it wasn't working. And now you have a merge conflict and now you got to go fix all these references here. Like this is my day to day, where I have to kind of deal with this, but very relevant for machine learning, right? This is typically how, if you're working in a production system, your machine learning workflow is going to be very much a part of this, right? You're going to have to integrate maybe a model, you have a code base, whatever it is, right? You're going to constantly have to check it in and share it with people. Now, right, closely related to this, go ahead if you want to say anything.
Oh, no, I was going to say, so it's like relevant to ML, but it's also pretty challenging with ML because of as we're talking about, so much of this is kind of Git centric, right? Like we're talking about Git branches, we're using a Git flow where we're developing features on a branch, and then we're considering if we want to merge those in. And Git does not play nicely with all machine learning projects.
Yeah, and we're gonna get into why that is, and in particular some of the challenges that happen with that. But related to continuous integration is continuous delivery. Now, before recording this, I botched this. I said continuous deployment. I said continuous, I forget what I said, development. I said all sorts of things because typically I just say CICD or a CI job. But what we mean by CD is continuous delivery. And just doing some research, it says it's anytime you're releasing, the ability to release at any time, right? To push to production at any time. It's also the ability to increase speed and frequency of releases. So you want to be able to do this pretty regularly, maybe, a couple times a day, even, push some changes to a model, put it back into production. It's really good too, if you can do this frequently. One, because it reduces risk, right? We talked a little bit about, holding or having a merge request open for too long. It also reduces cost if you can regularly fix things, regularly deal with issues, and re-release them. But also time too, right? I don't know what it's like I'm sure some people in the MLOps community have been in the software industry for a long time and maybe have a sense of what this was like before even some of this technology was out there, like GitLab or GitHub. But I just know that if it wasn't for the ability to use some of these tools, it would take a lot of work to or do this all on my own without Git,
Yeah, I also feel like I don't know what it was like in software development before this, before this.
Me neither. That's why I'm like, what is that?
So DevOps, luckily, I think it's been around for at least a decade now. I think it's, mainstream. Every major tech company, to my knowledge, is using some of these principles at least. And so I know that there was like a time before. I have this book that I'm going through right now, the DevOps Handbook, which is
nice.
This is like
we're gonna have to link that book. Yeah, we're gonna have to link that book.
It's a good one. It's really good, and I kind of recommend this. It actually is kind of written at a level that I think like a manager could get it. So it's a pretty nice
for a broad audience.
Yeah.
Nice.
Really good.
Books like that. Yeah, and it's like, the time before GitLab or GitHub, I don't know what that's like. For anyone listening, please let us know. Fill me in on my, I guess whatever it is, my chronological snobbery. I forget what author I read a while ago that said
Yeah,
that.
we're pretty lucky. We're like privileged to just show up after this hard
Yeah,
work has been done.
I
Uh,
know.
we already
Yeah,
figured
yeah,
out how to make this work. But like I have worked in, startups where it was not in place because of things were just too small, or, kind of junior. Like, and I had once, working on an ML model and I would work, like my job as the data scientist is like the only data scientist, right? And we had like one person who works on
do everything.
deployment for making the front end and everything. And I'd say, okay, I made a new model, let's test it. But then it would like, I think we actually just like, it went stale. Like they were like, okay, I will get to deploy this as soon as I'm done with all the other tasks. And it just
Oh
never
man,
happened. So like,
oh
there's
man.
no ability to have any feedback on how the model you've created as a data scientist is going to work in production. Like, I
Yeah.
didn't even know if it could work in production. Like if the dependencies were right, if it was going to break something, I had no idea.
I think that's one of the greatest things about continuous delivery is you get feedback quickly, right? Let's try out this idea. Let's see if this actually has impact on the business. And before I can imagine before that, it must have taken a long time, and you probably lost money, right? The quicker you can test out a good idea and put it in production, I'm sure the more or the quicker it could actually translate into actual business value,
Right.
so that you can get that
Absolutely.
feedback and do something with it. Because, like you mentioned, that sucks. Like probably like you have to wait because of all these other things happening, and then next thing you know, the model is stale. Maybe the distribution shifted or whatever it is that's going on. And yeah, so we've kind of been talking about some of these tools. Obviously, Git is a huge part of that. Not the same thing as GitLab and GitHub, but there are a lot of tools for this, right? To make some of this stuff easy. GitLab is what I use in my everyday work. GitHub is what I use for personal projects. I've heard of Jenkins. I'm sure there's lots of tools out there, but there's seems to be a good amount of tools in this space for DevOps, right? It's like you said,
Definitely.
it's been around for a little while.
Hmm. Yeah,
And
yeah, there's quite a good ecosystem. And, we're GitLab and GitHub are the two that I'm most familiar with.
yeah.
But yeah, it's a great ecosystem.
Yeah. And I guess what they're all trying to accomplish is some sort what I'm at least my gist of it is it's for version control, right? And there's a lot of other things that it can do, but it's the ability to version software, right? Especially when you have large teams. And that's what I think one of the great things about GitLab or GitHub is the ability to share, to collaborate, even at large scales. It facilitates collaboration, especially across cross-functional teams. When you have a tool like this, you have one place where you can store your code, check in your code, review your code, test your code. It allows you to make small changes incrementally, right? Continuously integrating those changes, continuously delivering them, and continuously getting feedback on them. But overall, it seems like a way to keep track of like what you're doing. I mean, that's what when I first learned about GitLab or GitHub, that's kind of what my first impression was. Is it's just a place to kind of keep track of everything. What is your?
Yeah.
How would you describe like this whole ecosystem? I mean, I know it does a lot of things, but yeah, go ahead.
Yeah, so I think that software projects they're complex kind of, and they're evolving, right? And they evolve in a couple dimensions, right? You've got that they change over time. You've got that they can have separate branches, so you can have parallel development. And then things get more complex, the more people you add, the more dependencies you add, you can have, and so GitLab and GitHub are tools and Bitbucket too,
Oh yeah, I
historically,
forgot about
they
that.
are also part of like code management, but increasingly things like GitLab CI or GitHub Actions are moving into more to do with having continuous integration be like a core part of where you're keeping your code. So it doesn't cover like the whole stack necessarily because of like there's still a need for like, okay, well, how do we version and track infrastructure? And ML is especially complicated because of you have infrastructure and data dependencies that are really non-trivial.
Yeah,
But
100%.
these are tools that I think kind of evolved from software, and now we're looking at ways to extend them
So
to
machine learning, yeah.
ML.
And I guess what all of them have in common is they all have some sort of web-based Git repository, right? So like I said, some place where you could store your code, share your code, test your code, collaborate, and all of these things, like we're mentioning, they're all relevant for machine learning, right? This is a big part of what the machine learning lifecycle involves. Another thing that I think is also cool about these tools, GitLab, GitHub, Bitbucket, is that they allow you to configure some sort of authentication, which is also important, right? Like my organization can have its own repository, its own Git or GitLab, I don't know what it's called, account. and it's secure. They allow you to provide role-based access even. Another thing is that it allows you, I think, besides this whole authentication, is automation, which we're going to get to in a second, that it allows you to automate a lot of things that maybe before you had to do manually. And oftentimes what you're doing locally, right? Oftentimes, I mean, if you're doing some sort of test-driven development and you're writing tests and kind of working your way towards a passing test, you're going to be doing this, over and over and over again. But it's nice when you have that also when, as you're making a change, pushing it to this mainline code base, you have it automatically tested. You're getting immediate feedback on, what went wrong, what went well. And another thing, I guess, is that it allows you to audit, right? To keep track of what changes someone made, right? That's a huge thing. And probably a whole conversation on its own is the ability to audit or monitor the work that we're doing. That's a big, monitoring machine learning is a big one, but also I think just generally just being able to see what the heck is going on. And I think another one that I could think of about all of these is it allows you to track issues, which I think is really cool. So I'm new to this whole like agile sort of way of working. Teaching is very different. But one thing that the way I typically work maybe is different for you, but we open up some sort of issue, right? Oh, this needs to be fixed or this needs to be done, this feature. And then it's all going to be on this GitLab repo. So you go check out the issue, you say who's working on it. You can kind of, continuously put updates on that thing. And then when that issue is done, you close it. So it's like also a place where you can track work, not only code, but assignments in some way.
Yeah, I mean, totally agree with all of that. I think I was most surprised when I started this job that, I had known about GitHub before and I was using it, in my capacity as a scientist, but I really was just using it as a file server. Like when I'm done with the project, I'll put it on GitHub so other people can have it. Here. And it's like, it's so much more than that. Like you really can use it. I think the power to go, have these really, like Git is a set of pointers, right? Like it's a graph of pointing to different versions. And it's great to have everything connected. Like at this point in time, this is the data I was using in the, my code. And this is, like my pipeline of perhaps, what I was going to do to analyze my data. And I mean, it's not always, because like I said, it can be complicated to do those things in Git, but it's a pretty powerful tool when you get it working for your setup.
Yeah, that's a great point when you actually get it working. Now, I'm most familiar with GitLab. So I know that GitLab gives you continuous integration for free, right? But what about some of these other, I mean, obviously a big part of the tool that you worked on, CML, which we're going to get to in a little bit. I keep saying that, but yeah, we're going to get to it. But yeah, that also integrates with GitHub. And does that provide continuous integration as well, or do you have to add things to that to get that?
Yeah, so I think it was in 2018 GitHub launched GitHub Actions, which is their CI system. I think it's fairly comparable to GitLab CI, at least at the level that I interface with them, which admittedly is probably not as intense as some people. But for me, I have found them both to be, fairly similar.
Nice. Good to know.
Yeah, so that one, so GitHub has GitHub Actions, just like GitLab has GitLab CICD. And I know Atlassian and Bitbucket has something also, but I haven't used it yet. And we have a lot of requests for that actually in the project,
really?
the email project. So I think Bitbucket will be something that we're, is a priority for us sometime soon. But yeah, so CML is not like, technically it's not a CI system, but it's a project that helps you use existing CI systems, which would be like GitHub Actions or GitLab CI.
So it's like an abstraction built on top of these continuous integration systems.
Yeah, it's a set of functions and some, we have some use cases developed so that you can help basically tie together the things that you might need for a machine learning project to use continuous integration. Basically, anyway, if you wanted to use GitHub Actions, but it was going to be hard for there's a couple reasons why it might have been hard, and we just set out to solve those, kind of give you some neater abstractions than having to write all your own, basically custom.
Yeah. And I bet you people have done that too. I bet you people have tried to build their own. I mean, that's such a common thing. This build or buy question. A lot of people just built something because, they needed that. There wasn't anything out at the time. People have done it, devoted a whole quarter's worth of work, building something. And then next thing you know, this cool tool comes out. And, I mean, I think that's kind of good though. I'm never mad for this new tool that makes my job, easier. But I do think that it can be hard. There's so many new tools coming out. So it's what I like about CML is that it already works with things that I would imagine a lot of ML engineers and data scientists are familiar with, right? Some sort of it's part of what their workflow. So it's just an additional tool that they can use that. It's familiar, which I think is also great. And that's, to me, sometimes that's important. You don't want to have to learn so many new tools. And there's a lot of tools in our ecosystem, right? I mean, all these libraries, even multiple languages at times. I mean, it's crazy, lots of craziness. And
yeah, it's interesting in that way, right? Because I mean, you don't want to have to learn too much new stuff. And so I think like for people that are already comfortable with Git or GitLab or GitHub, like this is easier than having like a whole separate stack, right? Like there's a lot of projects in the ML experiment tracking space that are like basically their own stack. So we're trying not to do that, to be getting in. But it's interesting then because of, like sometimes those projects that are their own stack, it might be built with data scientists in mind who are maybe comfortable predominantly with a GUI or a Jupyter notebook. And so for them to learn Git is, maybe more challenging. So I think we're still sussing out like, okay, at what level of abstraction can we help the most people?
I'm glad that you guys are thinking about that because, there's a lot of things out there, and the more that you could reduce the friction or I guess the ability to barrier to entry maybe to learn these tools and actually create value, the better. Now, this is a nice segue into what we've been kind of getting at now. CI/CD is great. It's been around for a while. DevOps is a well-known, set of practices. But CI/CD for machine learning is hard. I've outlined three things I'd love to talk about of why they're hard. One, there's data, right? You have schema changes. You have, your distributions changing over time. Volume, right? You have models, so you have some aspect of non-determinism, right? Things are random. Then you have the code, right? That needs to incorporate business needs and has to do with bugs and configuration. So there's lots of things happening. Oops. And they all need to be dealt with differently. So why, in your experience, why do you think CI/CD is so hard for machine learning? And maybe we can kind of talk through these points, or if you have more stuff, whatever you want.
Yeah. So, I mean, the data set's a really good one, right? Like when you have an ML model, that model is not just code, right? It also represents the data. And in fact, for like a lot of deep learning models, the data is really far more important than your architecture.
100%.
Right. So the data is like critical. And, a lot of data sets are not that easy to do Git versioning on, which is where DVC comes in. So DVC is basically a tool for extending Git versioning to large data sets. It is not a replacement for Git. It's just helping you use Git with data sets. And you kind of pair it up with like, an S3 bucket or whatever storage you like, so that you can kind of keep your data lives there, but it's still being versioned by Git, and you have a link to the data that's stored in your GitHub repository. So that's kind of the DVC approach for dealing with data dependencies. And that is kind of a piece that, if you have essentially Git tracking now on your data set, then you can use changes in data sets to trigger your CI loop. But if you didn't have your data under any kind of source control, then changes in your data set won't trigger the CI. It would only be changes in your source code. So you need to have data management and easy ways to, push and pull data between where it's stored and where you're going to be testing your model or training your model. I mean, all of these things are really non-trivial when your data set is kind of over, in not that large size. Like if you've got like gigabytes of data, you've got to start.
And that's typically it, right? Like you're, in production systems, you're typically working with lots of data, in the gigabytes range, right? Or even more petabytes, if you're working at a huge, I guess so. But yeah, the point is that lots of data, it's not easy to version that. I know that there's some workarounds, right? There's a LFS, large file store, whatever, that you can add. Like if you have like a big model that, like I've used that for, let's say, running tests. So we store like a training artifact in the actual repo. And that it was too large, so I needed to use that. So like there are ways around it, but it's not always that easy. Like you're saying, there's been some friction. It doesn't always play nice. DVC though definitely helps with that, which is great.
Right. I mean, it was kind of like there is Git LFS, but it's kind of another option, and so you don't have to use an LFS server. You can just use your bucket. I starting from scratch, I found DVC. I mean, I'm biased because I work at this organization now, but I did find it a lot easier to interface with than, getting into LFS.
Yeah. And this is great. So there's volume, right? You have sampling over time, you have schema, right? But now let's talk about the models. So now CI/CD for models is also tricky, right? You have lots of different algorithms that you may want to try out, maybe run some hyperparameter tuning. So there may be the need to retrain things, why doesn't that play so nice with CI/CD generally, like when you're working with traditional software?
Right. So if you are doing a CI system, some people are interested in doing model training in a CI system, like maybe the experiment that they would, commit and then use as the CI test would be something to do with model training. But it could also be that they've already figured out, the best hyperparameters for their model, and then they're just going to check in, that completed model into their CI system and then run some tests to evaluate it in a production-like environment. So there's a couple ways that people will end up working with models in a CI system, but kind of universally, ML models are, they're quite difficult sometimes. Even if you're working with scikit-learn and all of the things you're doing are just like matrix algebra, you can very quickly run out of memory on your laptop. It's very unpleasant to have to, it's not fun. So even if you're not doing something that requires a GPU, it can be fairly intensive. And a lot of ML applications do require GPUs. And so by default, GitLab CI and GitHub Actions, the runners that they're on are not, they might not be up to the task. So, we want to be able to let you use whatever resources are necessary for your project.
That's a great point. The compute that you actually need may not match what your CI/CD actually does, right? It's not meant to, have that large of a load. It's meant to do small things, run small jobs, run a suite of tests or something like that. So even that alone actually is a very tough challenge, right?
Yeah.
I'm sure there's ways, I've never heard of this, but I'm sure there's ways to, like, you can just use a GitLab runner with a GPU. Obviously, is that what, I guess we'll get to, is that what CML allows, or is there some other workaround?
So there's a couple workarounds. So you can create something called a self-hosted runner, and this is not special to CML, but like lots of people, you can use a self-hosted runner, which is a computer that you are managing. It can be something on-premise, it could be something in the cloud, and you are basically going to set it up to work as a runner. And that is like both GitHub Actions and GitLab CI make it very easy to do that. It's just a couple of steps. So you can do that. And then one of the things that we've been working on in CML is how do you actually provision some cloud instances? So if you're using a self-hosted runner, it's got to be on and listening basically. But how can we say, okay, every time I check in some code, let's automatically spin up an EC2 instance that has a GPU that wasn't on before and then turn it off when we're all done.
Yeah. So I bet you doing that without, some tool makes it hard. It's possible, like you said, but you may have to do a lot of work.
Yeah.
That's awesome.
And even our approach is like, it uses Docker machine for that too. So don't want to take all the credit there. That is, we built a use case, but we're working on some great work by the Docker machine team.
Awesome. And then there's this third component where we talked about, it makes it hard, is the code, right? So oftentimes machine learning code has to incorporate a lot of changing business needs, right? Things that are constantly evolving. Now, software, you can do that, right? There's oftentimes software is, built to solve some business problems. So that often changes. That's not new. But there's, I guess there's some added complexity to the code of machine learning code. Can we talk a little bit about that? Why is the code different from just regular software, or is it different?
Yeah, so there's kind of like this blurring between, so a lot of software projects now contain like an ML part, right? Like I find like ML is being applied in almost every domain. I think almost every business is using it in some way. And so you've often got software projects that are more traditional that have an ML component in them. It's just part of the stack. And so it's kind of interesting, how do we get that to play nice with the more traditional aspects of software development where people have all these practices? So, our philosophy is let's get people to use the same tools for versioning all of the code and the experiments that have to do with, your ML project as what's in the rest of the stack. And like I said, I think that works, it's not going to work for every team. Some teams will prefer maybe just to have a separate tool entirely for all of their ML experiments and testing. But our philosophy is kind of like, let's put this with the exact same tools you can use on the rest of the project.
I think that's great. And it's easier for someone like myself to go and pick it up, integrate it. Now I'm eager to try that out. So this is a wonderful segue into the last part. I would love to talk about the tool that you worked on, CML. So first off, what does CML stand for?
Yeah, it's continuous machine learning. And I think we picked it so that we could keep having projects that have a 3-letter acronym. So we have DVC and CML.
I love that. Nice. So CML. And so doing a little bit of research on it, it seems like it's built to address 3 needs, right? There's the data component. So how to handle these large data sets. There's a compute component, right? How do we use cloud compute easily, maybe or nicely? And then there's also the need for metrics, right? There's some way to have some sort of human readable report while you're doing all of this stuff. So let's talk a little bit about CML, and yes, just go ahead, whatever you want.
Cool. Yeah. So CML is kind of our first foray into CICD. We had a lot of people asking, in the DVC Discord channel, which is definitely like that's kind of our community hub. We have a really active channel there.
Nice. We'll have the link in the video. Yeah.
Yes. Yes, that's great.
Is it a Slack community? Sorry.
Just a Discord channel. Yeah.
Oh, Discord.
It's our support channel, but there's, people come in and like, there's a lot of predictable questions, but like, which are kind of clues when you get those over and over again, like, okay, we got to fix the docs here. But there's also like people who come in with these crazy scenarios and then they're figuring out a way that they're going to set this up. And so you read about scenarios and uses that you would never have dreamed of. And it's really interesting. And there's a lot of people who say like, I want to do CI. How do I do this with DVC? And so DVC had kind of solved like one of the parts about how do we, do data versioning and how do we let data set changes trigger, feedback from a CI system, and also how do we transfer? Because I mean, one thing that DVC, does really well is it's kind of a nice wrapper for transferring data from cloud storage to whatever machine you're currently on. It makes the syntax a lot closer to doing like a Git clone. So that's pretty nice. And so it makes it pretty.
There's like some syntax around like it's like you can connect it to like an S3 bucket. What is that called? There's like a word for it though. Like it's like you can like a connector, like a storage. I don't know what it's called, but you can point it to something that it can constantly look at.
Right. Yeah. You set up your data remote and then you can push and pull to that remote. And so it's like this really nice high level syntax, I think, for, saying, okay, on this, CI runner, then let's pull our data set. And that works pretty well. So we've got that. And
what about the compute?
The compute.
CPUs and GPUs, right? Using cloud compute. How does CML help with that?
So we created a use case using Docker Machine, like I mentioned, which is, this is all the work of our guy, David, who it's a pretty brilliant, I'm really impressed with it. I think it's like the coolest thing I've ever seen.
Wow.
So anyway, what it does is when you commit and you get that commit is pushed to the repository, GitHub Actions or GitLab CI will then use Docker Machine to spin up your own instance on whatever resources you had directed it to. Like if you have an AWS account, it can create an EC2 instance with the GPU you want, any AMI you want on it. So it's really nice. And then it will run your training job on that machine and then turn off the machine when it's done. And so I remember doing this for the first time and being like, I have just ran a computer that GitHub owns to turn on another computer that's like in Ohio, because that's, the zone I was in. And it's so powerful. It's so cool.
Yeah. That's it. I never really thought about that, but yes, I'm like, telling this computer to do that and then do this. It's like, a lot of orchestration. Is that also a part of the challenge with, I guess, maybe doing CI for machine learning? Configuring all of that, is that a challenge as well?
Totally. I mean, there's a lot of work in infrastructure as code. I think a good project there to check out if you're interested in it is called Terraform. And it's basically all of, how do we codify the infrastructure we're using? Because of, the ability to replicate a machine learning model, a training run or a test run of it is going to be fairly contingent on a lot of cases on your infrastructure. So you need to have it versioned in some way and able to recreate it. Like one of the DevOps principles is also make it easy to completely recreate the environment. It should be something that we can destroy and recreate from scratch in a few minutes.
I think that might be hard. Maybe you could speak on this too, but do you think for the more researchy oriented people, I don't know how to say it, is that hard to think that way, that what I've been spending all this time on may, have to, be torn down, and I might have to start all over again.
It's really, it is completely new to me to be thinking about, I mean, I always, to some extent, was thinking about the infrastructure because of it was always like there. Like when I was doing research, we didn't really use cloud services at all. So it was kind of on my mind, but more in the way of like, oh, I really hope nobody spills juice on the file server today,
Yeah, that's crazy. So many different sets of problems. And then the last part of all this, right, is in machine learning, you need to know, are you improving, right? Am I doing well? Am I doing bad? So you need some way to also have metrics, right? Some sort of human readable report, something that tells you how we're doing. Why is that a challenge for machine learning, and how does CML also help with that?
Yeah, so, in a lot of CI systems, they're kind of built for pass-fail type notifications. Like by default, you get a binary signal of like, did the runner complete the job or not? And sometimes that is totally fine. If you have that and the logs from the runner and, you can figure out what the error was, and it's great. But ML is, it's really challenging to, you often need, in addition to some really detailed metrics being reported, data viz helps a lot, some kind of dashboard. I think that there's so much like ML models themselves are really high dimensional. You've often got millions or billions of parameters. Your data set is a very high dimensional thing. And a lot of these things behave non-linearly. And so, it's often not enough to just know like, okay, did I get above a certain score, on some accuracy metric? Because you need to know, okay, well, in certain subsets of the data set, which could be really critical, how well did it perform? What are the features that I'm using? Am I okay with these features being used? And so you really need that information, which is hard to get and often hard to do with complete certainty. But you want to make educated decisions about what model you're putting out into the world. And, I think you need to look at it from a couple angles.
Yeah, visualizations are key, right? Especially to communicate to maybe non-technical stakeholders, the ability to show a graph that says one thing and, communicates it very clearly. It goes a long way. Can you talk a little bit about what is possible with respect to visualization and metrics? Like, can any sort of visualization, or is there certain things that you can do?
Yeah, so we made CML to work we're trying to be pretty agnostic to what kind of tools people already like to use. I know people are so particular about their visualization libraries, and like, I get it. I don't want to use Matplotlib. I'm sorry, I'm sure.
Yeah.
So if people are really particular, so we made CML so that it actually works with any visualization library, because it's not really in your code at all. Like, it doesn't work at the level of like, it's not something that you put in your Python code and have it monitor what you do or anything. It's like after your script has run, whether you used R or Python or whatever, if it produced like a PNG file using any visualization library, you can then put that file in your CML report. So CML reports are kind of our way of displaying more information on a pull or a merge request. So now, instead of having just like, a log output from the runner, you can return images from the runner as well. And that could be data viz, it could be a table that you have. It's just a markdown file that you can stick whatever you want in it. You can actually put sound files in it too. Wow. I've never had a reason to use this, nobody has. But technically, you can put like any kind of file you want.
Interesting. Maybe you have like, I don't know, if you're training your model on like, acoustics or something like that, and you want to hear the predictions. I don't know, but that's cool. And can you, how easy is it to use these tools? How, in your experience, talking with a lot of different people, showing them how your tool works, for people that are curious of getting started with this, playing around with it, what should they do? How would you recommend someone going about learning this? Are there some tutorials maybe that you could point us to? We can always link them in after, but yeah, what are your thoughts on that?
So there's lots of writing about continuous integration, but I would probably, if you're a data scientist, I would maybe not recommend starting there. I kind of think like when you see it working, I think seeing it the first time is a better way to understand what the terms mean than just reading it. I had been reading for months when I started this job, and I don't think it really clicked until I just made a GitHub action. Like that was the moment. And making a GitHub action is not like crazy hard. I mean, it's actually pretty much you put one file in your GitHub repository. And I think GitHub has some amazing docs. I'm sure GitLab also has like some getting started docs, which are really solid.
Great docs. Shout out to GitLab. I love your docs.
Fantastic. Okay, so go to those. And when you see it working, like you'll be like, oh, okay. But like if you just read it, it can be kind of hard, I think. At least for me, I found it quite challenging.
You know, I get that. It's like, this is a very hands-on sort of thing, right? You need to kind of see it to know how to use it. Now, I just want to shout out that Elle has started a series, right? You've done a series on CICD. Can you talk a little bit about that so anyone's interested in watching that?
Yeah, so we're getting started a video series. Like, you know, we were blogging about this a little bit, but just kind of figured, let's just show it. At the DVC YouTube channel, which is just, I mean, if you just Google DVC,
Gotcha.
I think DVC YouTube channel, yes. We are in some like SEO competition with the Disney Vacation Club, but I think we'll be fine.
Oh man, that sounds interesting. Okay, cool. So I'm definitely, what I'm going to do is I'm going to make sure that everyone has links to this. And please feel free to reach out to me or to Elle, of course, about how to use this. I think she's posted some stuff on the channel, but yeah, I was poking around. I love the videos. I love the blogs, but I do agree that it's great to see it, right? Like I want to show me how to use this thing. What does it actually look like, right? Because yeah, sometimes reading this, it's, especially, again, I know a lot of data scientists come from all sorts of backgrounds, but I know many that are just, you know, DevOps, it's like, oh, I don't want to deal with any of that. So when they look at all this, it's just like, you know, what is this? But when they see it, it's like, okay, I could do that.
Right.
This file, you know, it seems less intimidating or maybe less confusing, because I know learning about a lot of these engineering things can be a lot. You know, I've already spent all this time studying the algorithms and knowing how to model. I have, you know, all these things that I had to learn, and now all these other things, you know, and I feel that we talked about this before on a different show, but these quote unquote full stack data scientists that have to know everything, you know, and this is nice because you're doing that. You're doing DevOps, right? It's definitely all when that, you know, that ballpark, but it seems like it's I guess much more user friendly, you know, especially with something like GitHub, which a lot of people use. Like I remember years ago, I was just using it to store my code and use it for like my resume or something, because that's literally all I knew how to use it for. Here, look at this link where I have some code and stuff.
Yeah, I mean, that's pretty much how it started for me too. I sometimes want to tell people like it's totally okay if you find it quite difficult to really figure it out. Like it's not that, I didn't find it that easy.
Yeah, I'm glad you brought that up, because, you know, in our field, you know, I guess it's just the nature of the type of people that are attracted to it, but there's so much going on. It's okay to say, I don't know how to do that. This is tough. I know that, you know, there's different opinions on that, but, you know, I guess maybe as a former teacher, I want people to learn, and I want people to know that it's okay if it's not immediately clear to you how to, you know, use all of this stuff or even understand all of it. But I think, yeah, like tools like this make that easier. You know, there's a lot of tools that are coming out there that make what used to be a very complicated process now like easy, you know, and a lot more simpler. And I'm sure that there's some trade-offs there, right? Maybe, you know, you don't have to learn all of this background. I've heard that before, where, you know, people talk about, you know, these new data scientists that don't know anything about some of these things or this concept. But at the end of the day, you know, this again, whatever works, if you could do it, I'm cool with that. I do think it's important to learn some of these things if you're interested, but you don't have to. You know, I think you can be effective in your day-to-day just using a lot of these great tools out there. And if you create value for the business, then what else really matters, you know?
That's so well said. I mean, I really worry sometimes about, you know, data scientists that have this weight of like, oh my gosh, I have to be a unicorn. And I think businesses are still figuring out, like, you know, how do we make data science work in our company? And there's a lot of positions, like I definitely interviewed for some that like, I'm pretty sure it was just a regular software engineer job. That
I bet you it was, yeah. Want to know how to build this, you C++, have like 5 years of software. I'm like, man, this is, I mean, I get it. You know, but yeah, there is a lot of that, you know, and I don't know. There's been some opinions. I follow some people on Twitter. I'm not going to say no names, but some very famous people who have big names in the game that, you know, have opinions on these things. But I think, you know, it's okay. It's okay to not know everything. I mean, for anyone who's heard me on the show, there's a lot of things I don't know. I'm constantly learning. I bet you're learning every day. And to be honest, I would put my money that a lot of us are all still figuring this out. Even when I went to grad school for data science, it wasn't really like, it's hard to teach this. This is a new thing. It's like a moving target, you know, and yeah, there's some old things there, right? You know, math has been around for a while, statistics has been around for a while, but it's in a new context. And there's all these other layers too, where like you have to integrate into the business. And even that alone, integrating machine learning into or data science into your business and applying it effectively is not easy. It's non-trivial. There's a lot of moving parts there, right? There's this tech part, but then there's this cultural part, all sorts of things going on. And it's okay to not have it all together. At least that's what I think.
Yeah, I totally agree. I mean, I really think that the majority of organizations like scientific, nonprofit, business, you know, that are using data science have still, I think there's still a lot of struggle to figure out, you know, how do we actually create something valuable out of this and kind of use it to inform the way that, you know, we grow or what our services are. And, you know, it's not easy. I think there's quite a lot of reports out there about, you know, the failure rate of data science projects is kind of high. You know, it's
kind very high,
right?
I've heard stats of like 80% of them or so, I don't know, like some crazy
That's the number I've heard too.
Yeah, and it makes sense too, because I've, you know, working in this, you see like there's a lot of like failure, you know, and I think now that I'm thinking, I feel like you're perfect for this because you come from that research background, right? You understand what it's like to, you know, have a lot of ideas, hypothesize about things and go off on these tangents. But now working more closely, I guess, with the engineering side of things, you see how important it is to structure that process, you know, and it's great that you kind of hold both things, you know, you have a good sense of how important it is for someone to experiment and play, and that's important, right? But also how to productionize it, how to actually make it valuable for the end users. And, you know, it's like a tough thing. You have to learn you have to know a lot of different things. And it is a lot of, I guess, there's a lot of things you need to know. And yeah, I feel bad for people just turning in sometimes because I'm like, man, I don't know how I did all this, but I know how to use this stuff now. But it's constantly, it's a constant process of relearning something, even something as old as Git. Like I'm learning new tricks with Git sometimes.
Right.
And that's like such a basic thing for some people, but I'm like, no, not always, you know, it's not always easy to debug, you know, a bunch of stuff going on in that. And yeah, but anyways, I feel like I can go off on tangents on that.
No, I mean, I think that's so interesting. I guess I'll just say that I think the cool thing about MLOps in particular is like, I feel like sometimes it's so easy to get into the place of like, well, data scientists just need to do more of this or something, and that will fix everything. Or, you know, businesses need to do this. And I feel like MLOps takes the perspective of like systems level, you know, it's not really about blaming anybody or putting it on individuals as much as it is about okay, where in the whole process does this break down? You know, what are the real bottlenecks to preventing things from going into production or even just getting tested in a timely way so that data scientists get good quality feedback, you know? I love that perspective. I think it's probably like, it's just, I think it's really illuminating. And even just like reading a book about DevOps, it like can really shift your thinking to, you know, thinking about organization.
Didn't they get excited to like, you know, structure? I mean, for me, when I was like learning a lot of this stuff, I was excited to try it. I'm like, oh, this sounds awesome. Let's use this. It'll make things better and more productive. But you know, it does. Like for me, when I first started learning about test-driven development, it was more so to cover my own ass. Like I make so many mistakes, and so I write tests to protect myself, to catch those mistakes. So when I publish it, you know, I don't look crazy. But it's really like these for me. It was helpful. You know, all of these principles, all these practices actually have made me a better data scientist or ML engineer, even more structured thinker, I would say. And now I start seeing the world in a new way because it's like, I don't know, I love the engineering side of this, so I guess I'm a little biased, but I love that I guess that gap between, you know, there's all sorts of ideas. It's crazy, you know, there's all stuff going on, but then the productionizing it, you know, they're very different, but they're so important, and it's made me a better, you know, I guess worker, you know, knowing how to integrate these two things. Well, this is so much fun, Elle. I want to thank you so much for taking out the time to first talk with us, give us an idea about what CML is. I would love to maybe even further this conversation another time, so we'll touch base about that. But for anyone that's interested in listening, please reach out to Elle. She's very easy to talk to. There's a lot of great content that she's putting out. I'm going to link them inside the video. And yeah, this is really fun, guys, and we really appreciate the time that you took to listen to this. And Elle, maybe one thing to close is, since you learned a lot of lessons, I bet, you know, through a lot of failure, a lot of trying things out, what's one takeaway that you'd love to share with the community? It could be anything, something small, something big. what's something you'd like to share with us? Something I like to do at, MLOps communities, we want to share best practices. This really worked well with me, or I learned this lesson and I want to share that. What's that one thing for you?
Yeah, I think that maybe my favorite lesson from DevOps that I've learned so far is that when people are failing in your project, if you look that there's somebody who's failing by whatever you consider it, kind of try to take the most blameless post-mortem possible and think, this was a system that enabled somebody to, not get something right. And so taking the perspective, that there may have been a way that the whole systemically we could have prevented this. Like if somebody forgot to do something, maybe that was a thing that should have been automated in the first place. Maybe there was too much cognitive load for people to handle all of these manual steps. Maybe something took a while because there was a bottleneck in handing something off that could not possibly have been remedied because of two teams had competing interests. So I think that taking the perspective of, are we really set up for people to be able to move quickly before, I think that's so valuable and it's been like a life-changing way to rethink.
Yeah, that is. It shapes the way maybe you view your coworkers. It's like maybe we have not necessarily like I don't know, but I don't want to ruin that. But I love that, and I hope for anyone listening that that you apply that. I know for me, one thing, something maybe not exactly related, but this concept of I'm not my code, and that it's people putting so much importance on like these small failures when it really may be just an operational thing, right? If we had this in place, this one person will have to do everything, and I guess showing a little bit of grace that this is a growing field, things are changing, and I think that actually that's something I'm going to definitely think about because I deal with that every day, right? But anyways, I want to thank you so much for this time, Mel. Thank you so much for sharing with this, and I hope you have a great rest of the evening.
Thank you. Yeah, thanks for having me. I really love this community.
Awesome. Bye, guys. Take care.